Welcome to the stage, Teradata's Chief of Staff, Yasmeen Ahmad.
Do you feel like you're living in a hyper-disrupted world? Has your organization been on a digital transformation journey that never seems to end? The first experiment was easy. The second and third project we pushed into production. But the idea that our businesses will be based on data-driven decisioning, or analytics will be pervasive, does that sound crazy? Well, today I want to look at how do we scale? Specifically, what does it mean to scale? As organizations embrace hyper-disruption, focus on pervasive digitization, does scale mean adding more humans? Humans aren't scalable, and actually creating more models, millions of algorithms, just sounds like more complexity. And as we bring in AI, machine learning, does that mean we throw out all of the models we built before, the traditional statistical work that we've done before? And finally, if AI, machine learning, if analytics are such a differentiator, then why are our organizations finding it so difficult to adopt? Why are they finding it difficult to access those $100 million business opportunities that are promised from the use of data and analytics? As we look at these three themes today, we're looking at the next era of data-driven enterprise, where success is not achieved by those who collect massive volumes of data. Success is achieved by those who learn to scale, integrate, and transform their workforces. Because let's be clear, the business of today is a very different business. Businesses today are leveraging platforms, networks, and data to create differentiation. Just take a look at what Amazon did with the traditional bookstore. Amazon took a physical channel, the bookstore, and converted it into a digital retail channel, the website. But actually, Amazon took it a step further. They took their product, the physical book, and they made it a digital software asset, the e-book. To varying degrees, all businesses are leveraging data to change the channels, the products, and services, and in some cases, replace their products, services, and channels entirely with data and digital. But what does this mean for us as consumers? Well, previously, as a consumer, it was actually the business who was empowered. The business decided which 5 brands to display on the shelf. You as a consumer only had the choice between those 5 brands on the shelf. But today, in this increasingly digital world, we see an empowered consumer. This is the global citizen who can reach around the globe for products and services that they never imagined before. But as an empowered consumer, with so much choice, we actually feel overloaded at times. There's so much choice, so many decisions to be made. So as businesses, we now leverage algorithms to personalize, to target, to cut through the noise to ensure our product and service appears in front of the consumer. But actually, consumers are leveraging algorithms too. Think about your Alexa. When you ask Alexa to add milk, eggs to your basket, does the Alexa ask you which brand you would like? No. Algorithms are leveraged to look at the brands that you've bought in the past, the brands that your family buys, the brands that your social connections buy, to look at your personal preferences. The algorithm makes a decision on behalf of the consumer. Think about the last time you did a search. Did you look through all of those 200 pages of search results to find the product? Or did you rely on the algorithm to find the most relevant products and put them on the first page? Increasingly, in all aspects of life, we are relying on algorithms, not just to help us, but in many cases, make decisions on our behalf. From healthcare to transportation to retail, every aspect of life is being driven through millions of algorithms. So as organizations and businesses, how do we step into this algorithmic world where we have to build these many millions of models to support our customers, our citizens, our consumers? If we look at the analytic workflows, and Oliver spoke about on Monday, that workflow is super inefficient. 90% of the time is spent by humans looking at data, wrangling that data, cleansing that data. And then when we try and push things into production, again, it's difficult. This analytics workflow is not designed for the millions of algorithms we need to build for the future. So we have to rethink that analytics workflow. We have to rethink this as an analytics supply chain. How do we optimize our analytics supply chains to be ready for the future? And the supply chain is not optimized by throwing more humans or time at the problem. We have to look to operations and algorithms to see how we can optimize these supply chains to deliver more outputs, to deliver more algorithms, to deliver more insights. What do I mean by operations? Well, think about the software engineering world, software developers, coders. Software engineering is actually a fairly mature field. They've learned how to develop code, share code amongst developers, check that code in, have test suites that ensure the code is correct, have continuous integration, continuous deployment so that code is promoted into production. That's operations in action, DevOps in action. In contrast, if we take our analytics workflow, the analytics field, it's still in its infancy. We don't have that operational rigor, that operational thinking in the analytics field. We need to take concepts like DevOps and apply them to analytics, analytic ops, to help us with operationalizing those analytical workflows, helping to make our analytics supply chain more optimized. But it's not just about operations. As you heard Stephen talk about, we can actually leverage algorithms within that workflow. We can leverage algorithms that are automated to, again, give us speed, give us efficiency. Just imagine a next-generation analytics ecosystem, a platform that gives you capabilities like outlier detection, PII detection, identifier matching. Imagine as your data streams in real time, there's a data firewall that is continuously looking at the data, looking for anomalies, quarantining data that looks suspicious. As a human, I don't have to be active in cleansing and looking through and sifting the data. I now rely on the algorithms to flag when there's a problem. Think about a next-generation analytics platform with capabilities like version control and A/B testing. When Teradata introduced version control to Vantage, we did that because we heard from customers, especially from customers in regulated industries like government, financial services, that it's key. We have to be able to explain our decisions. We have to be able to go back in time 6 months, 5 days, 2 hours to look at exactly which version of algorithm was running, what was the version of data, and what was the version of output that was being created. Version control becomes increasingly important as we look at continuously evolving our algorithms. Think about A/B testing. Your analytics ecosystem will pit multiple algorithms against one another, and it will decide which algorithm is performing the best and promote it into production, all happening autonomously. And it's only through thinking about operations and algorithms and automation applied to our analytics supply chain can we really think about scaling as businesses and organizations. And as we scale, We can now refocus the human effort from wrangling and cleaning data to focusing on the analytics itself, building those models, looking at the insights. And now seems like the perfect time because we've got AI and machine learning. And if the AI and machine learning hypes are to be believed, AI and machine learning will take over. Can we really throw away all of the effort, all of the models we've built in the past? Is AI and machine learning really better? Well, if you look at this study of 1,000 time series data sets, we actually see that the traditional statistical methods often perform better. We see here that the traditional statistical methods are less complex and have lower error rates as compared to AI and machine learning. Why? Because these algorithms are different in the way that they operate. A traditional statistical method is based on logic, if, then, else. Whereas an AI algorithm, it works through test and learn. You feed AI algorithms millions of data points, and they rely on millions of repetitions of the same patterns to be able to learn patterns and make predictions. So actually, different algorithms are important depending on the data you're looking at. Traditional data, transactional data may be better suited to statistical methods, whereas the clickstream, IoT, sensor data, where we're looking for patterns, may be better suited to the AI algorithms. Let's just take an example. So here we worked with an insurance company, and they were looking at risk. And for an insurer, risk is very important because risk is related to price. If you're a high-risk driver, price point premium is likely to be high. If you're a low-risk driver, then premium is likely to be low, the price point likely to be low. So as an insurer, it's very important to understand the risk profile of a customer. But risk is not so easy to understand because risk is a multidimensional problem. There's risk from cars being stolen. There's risk from a driver having an accident. There's risk from vandalism, risk from various factors. And as an insurer, you need to understand all of the risk. So if I start thinking about driver behavior, I actually potentially want to use all of the sensor readings that cars are collecting to analyze behavior. This is where an AI algorithm can be great. We can take driving behavior from thousands, hundreds of thousands of drivers and train the model and get it to understand what does positive behavior look like, what does negative behavior look like. If a driver accelerates, decelerates really quickly, does that make it more prone to risk, more prone to accident? The AI algorithm can learn these patterns. On the other hand, if I'm looking at the theft of a vehicle, I'm thinking, is the car parked in the garage overnight, or is it parked on the street? Where does my driver live? Do they live in a city? Do they live in the countryside? What's the zip code? Which geography does my customer live in? And actually, that problem can potentially be solved with a decision tree that gives you the risk of the car being stolen. And so with each risk, we can look at different types of data. We can match the algorithm to the data to the problem, and we can come up with risk from multiple algorithms and combine those algorithms to get a much better prediction. And we see this across industries in many business use cases. And in fact, we also see this pattern in data science competitions. If you're familiar with Kaggle or KD Cup, these are data science competitions where often individuals will first start alone, building their algorithm. As the data science competition progresses, multiple individuals will come together as teams. They'll combine the algorithms they've been working on into one integrated solution, a solution that has far better predictive power than any algorithm on its own. The diagram here shows the winning solution from the 2015 KD Cup data science competition. And you can see 64 different models being combined. And as we combine these models, we don't have to give them all equal weight. We can say our AI algorithm is twice as important as the decision tree or the logistic regression model. Or we can actually use another algorithm that helps assess how to combine these predictions together to come up with this solution where you have much better predictive power. And so with the addition of every algorithm, we're looking at more data, we're looking at more dimensions of the business problem, and we're increasing the value that we're getting. We're increasing and maximizing the insight. So through these optimized analytics supply chains and through a diversity of algorithms, multi-genre analytics brought together, we can now move forward with AI machine learning. However, we still hear from businesses around the globe that despite the billions of dollars of investment in hardware, software technologies, our organizations still find it difficult to adopt analytics, to do analytics at scale, to implement data-driven decisioning. Why is that? Well, actually, hardware and software is not the issue. The issue in many cases is the wetware. It's the human and the organizational factors. In fact, Teradata just did a study in which our customers cited cultural resistance, lack of organizational alignment as two key factors in success with data and analytics. For the workforce of tomorrow, we need to reskill our humans to work together with algorithms to create value. As we take humans from what they've been doing today to the future workforce, we need to retrain them to be able to work with algorithms, to be able to understand algorithmic outputs, to have the quantitative reasoning skills to interpret insights. We need humans who are good data storytellers, who can interpret data and advise their leaders on a course of action. And the human is integral, because these algorithms are actually very narrow. They perform tasks very well. I can get an algorithm to give me a prediction, a number. But often, to access the $100 million of opportunity, we don't need just a task to be completed, a predictive number. We need to re-engineer entire business processes. And this is where humans and algorithms need to work together. And in fact, as humans and algorithms work together, we see human behaviors adapting. So much so, the algorithms are actually changing the way our brains work. Algorithms are rewiring our brains. A recent study, the Google effects on memory, showed that when we are now presented with a difficult question, we're less likely to recall what the answer is. Instead, our brains are being rewired to now remember where to find the information. So presented with a difficult question, you won't remember the answer, but you'll remember where to get the answer because we've got information at our fingertips. So as humans work with these algorithms, we need to work closely, not leaving the algorithms to do their job, but to integrate with those algorithms. Because left alone, actually, algorithms will just do stupid things much faster with more energy. What do I mean by that? Well, when we train an algorithm, especially when we look at AI machine learning, we feed it lots of data. And it looks at that data, it looks at millions of repetitions of patterns, and it learns from those patterns. But typically, those data sets are fixed point in time to the current business context. But we know as businesses, cultures are constantly evolving. Consumer behavior is changing. The business context is evolving. So we need humans in the driver's seat to govern the algorithms, to understand when algorithms need to be retrained, perhaps with new data sets. We need humans to understand when the business context is changing, because algorithms don't think, they don't want. Neuroscientists talk about this idea of motivation, of wanting. It's a biological privilege. Actually, algorithms don't really understand the relationship between variables. Variables like race, social economic status, gender. But as humans, we understand the relationships. There's many stories today of when algorithms have got it wrong. Just to pick on one story, a South Carolina man applied for a home with his wife, and they were rejected. Their application was rejected. An algorithm that performed a background check rejected his application because it matched his profile with the profile of a sex offender in a database. Serious consequences when algorithms get it wrong. That gentleman was able to go through the lawsuit and get the error corrected, but by then, weeks had gone by and the home was gone. Humans play an important role in governing, monitoring, and managing algorithms in a future world driven through algorithms. So to summarize, if our organizations are really going to move to that next level decisioning, where decisions in the enterprise are driven through data, analytic insights, we have to look at our analytic supply chains. How do we scale those analytic supply chains through analytic ops, through automation, through algorithms? How do we use a diverse set of algorithms to maximize the amount of insight from every piece of data that we're collecting to give us more predictive power? And finally, it's not about the tech or the software. Tech and software on its own won't solve the problem. For our organizations to truly embrace a data and analytics world, we have to reskill our human workforces. We have to change the role of the human to help govern, to manage the models that we're building. So I leave you with the challenge. How do you scale your organization to tap into the $100 million opportunities that are out there with data and analytics?